Question 31 is a funny one. It's looking at even and odd numbers. If you think of a letter that represents a number, n could be 1, 2, 3, 4, 5, 6, 7. N can be odd or even. If we double a number, 2n, if n is 1, then 2n is 2. N is 2, 2n, 2 times n is 4. N is 3. 3 times 2 is 6. So 2n represents even numbers. If we want an odd number, we take an even number, 2, 4, 6, 8, 10, and we subtract 1 from it. So if we've got an even number, 2, 4, 6, 8, 10, for instance, and we subtract 1, we get to 1, 3, 5. So these are only odd numbers. This is a tricky concept. If you do not get the question, it is absolutely fine. It is a grade 5 question and it is tricky. The correct answer here, I'm going to show you the correct answer first of all. It's D. If we take that bracket away, it becomes n plus 1 plus n subtract 1. There's no multiplying here, so we literally can just take the brackets away. This simplifies to 2n. Add 1, subtract 1, we are just left with 2n. The other options that are here, A is n plus 1, n subtract 1. If we expand this bracket, we're going to start with an n squared term and then something. Now, n squared, 1 squared is 1, 2 squared is 4, that's even, 3 squared is 9, that's odd. So n squared in itself doesn't give us an even number. This is actually n squared subtract 1. 2n subtract 1, as we said above, is odd. It's an even number, subtract an odd number. And the last one is n plus 1 squared, which is the same as n plus 1, n plus 1, multiplying again, it equals n squared plus 2n plus 1. You can expand that for yourself if you wanted to check that. We're now on to percentages. Oh, ratio and proportion. Now, when we change to a different topic, they start more gentle than some of the questions we've been doing already here. I'm going to give you two options for this. If it's a non-calculator question, we need 15% of 900. And so what I would do, there are lots and lots of different methods for this. I like this, putting it in a sequence, a list. Choose what you want to call it. I'm dividing 100 by 10. Therefore, I divide this by 10 as well. This gives me 10%. 5% is when I divide 10% by 2. I do the same to this side. And then what I'm going to do, 15% is like 10%, add 5%. So it's 90 plus 45, and that gives me £135, which is answer C. If it was a calculator question, we could do exactly the same, but we can also use the fact that 15% is the same. 15% is the same as 0.15, and then we can just put that straight into our calculator, and that gives us 135 straight away. Again, I'm going to give you a calculator and a non-calculator. Non-calculator, we're looking at finding 12%, or we're looking at finding 88%, depending on which way round we want to do it. In fact, let me start with the calculator. If we're doing 100 and we subtract 12, that gives us 88. So we can use the fact we're looking at 88%. 88% is the same as 0.88. And just like we did before, we could take 25 and multiply by 0.88, and that gives us 22 kilograms. And that is C. Another way to do it is to step down. I tend to find 12% first. Here we went straight to 88%, but I'd find 12% and then take it away from 25. So just like I did above, 10%, we divide it by 10. 1%, we divide it by 10 again. We're going to double this. So here we're multiplying by 2. And then 12% is 10% plus 2%, which is 2.5 plus, well, I'm going to put it down here, 0.5, which gives us 3. We then take the 25, the original kilograms, we subtract 3, and that gets us to our 22 kilograms. Oh, down here. Question 34. Oh, there we go. The ratio of water, juice to water. So we're looking at juice to water, and it's 3 to 2. I love boxes. If you've ever worked with me, you know that. It's a total question. We are told the total amount of drink is at 600. The total question, we have to add these two together. And what we do is we take our 600, which is our total, we divide it by the number of boxes, we get 120. And if we're after the amount of juice, it's 3 multiplied by 120, which equals 360. Are we on milliliters? Yeah, which is B. Question 35 is just there. We're looking at 2.8 kilometers and we're turning it into meters. The magic number, kilometers to meters, is 1,000. Often the magic number here. You can do this as a calculator or a non-calculator question. We're in meters, and that's answer A. Question 36. So this is what's called a reverse percentage question. It even gives you the clue here. This is when we've got the sale price of something and we've got to get to the original price. So this is not the original that we take 20% from. This is what we're finding is this is actually 80% of the 100%, 80% of the original price. It's 80% because 100 subtract 20 is 80%. We start this time with 80% equals that sale price. We want to get up to 100%. So what I'm going to do first of all is take it down to 10%. Now, if this was a calculator question, we could go down all the way to 1%. I'm just going down to 10% because if this was a non-calculator, then I'd rather go down to 8 than divide this by 80. You divide this in whatever way works for you. I'm going to assume I've got a calculator and I can just put that straight in. We then bring it up to 100%, which we're going to multiply by 10, which gets us £180, which is answer A. It's called exponential growth. It's the same as compound interest. This is how you might know about this question. So we're looking at the original amount. We're looking at R and we're looking at N. R is the rate, N is the number of years. So the original amount is 800. R is 2.5 and N is 4 years. Now, the formula on the formula sheet, it says that the new amount, it doesn't quite put it in these words, but the new amount equals the original. And it puts something that looks a little complicated. However, oh, that's an R. It works. So if you don't remember the formula in any way that you've done it, use the formula on the formula sheet. And then substitute 800. 1 plus R is the rate, 2.5 over 100 to the power of 4. We put that into the calculator, we get 883.050. And where the answers show it to the nearest pound, that means that we're rounding to the ones place in terms of £1. So this is 0, 3 doesn't change, 883, which is answer A. Okay, so when I do a speed question, what I will do is I will write out speed, distance, time. Speed in this question is 15. Distance is 84 kilometers. Now I'm checking my units. Kilometers. We're going to want our time in hours. This is going to give our time in hours. I think about the relationship speed equals distance over time. And then I will put that information into a triangle. You might have other ways to do this. This will show you the equation you need to use. Time equals distance over speed. 884, which is your distance, over speed, which is 15, is the same as 84 divided by 15, or you just put it into calculator like this. This gives you 5.6 hours. And that's answer D. Or I can just squeeze it in. All right, question 39. Density works in the same way as speed. Let's move this down a little bit. Density, mass, volume. Now, if you can't remember what are the different things to do with density, mass, volume, you can see we've got volume here, we've got density, and this is mass. So you can pull those words out, even if you can't remember the order. Density is 8.6. Mass, we don't know yet, but it is in grams, which is the same as here. And volume is 120 centimeters cubed. We have a triangle here. Density is what's called our compound, kilometers per hour, grams per centimeter cubed. This is our compound measure, and it goes in the corner. It's the first one here. We're then doing mass and volume. The mass is the first thing when it comes to density. Mass is in grams. We can see that here as well. And mass is the one that goes up here. This is not on your formula sheet. So if you don't know this already, do practice it until you remember. Okay, we are looking for mass. We have density, volume. And this time we're taking the mass is going to equal the density multiplied by the volume, which is 8.6 multiplied by 1.0. no, 120. And that altogether equals, put it into your calculator. Question 40, proportion. Now, this, we need to use logic. We need to think about, if we reduce the amount of workers, will the amount of time taken to build a wall increase or decrease? So if we reduce it to one worker rather than the 6 workers saying at the same time, this will go up, this will go down, this will go up. So it's what's called an inverse proportion question. And we can use this process again, but we've got to be careful, because when one side goes down, the other side is going to go up by the same amount. So we divide, the inverse is to multiply, and this comes to 72. Put it into your calculator. We want 4, takes 4 workers, and therefore we're going to divide this time by 4, and it takes 18. So the answer is 18 days. And that's answer C. New topic. Okay. Question 41. Which of the following shapes has no line of symmetry? Well, the only one on here that has no line of symmetry at all is a parallelogram. And that is answer B. Oh, this is question 41. Question 42. If we look down those facts, have a careful read, we can see that what we're doing, triangles add up to 180, angles on a straight line add up to 180, angles around a point do not add up to 180. The answer is C. So angles, a point, do not up to 180. It should be a little confusing because it says the following is not. So the answer is C. It's the only one that is not correct. .43 is actually over here. Now, we've got this, and we can see that these two are parallel lines. What I do here is I will actually extend these parallel lines. And then it starts looking like a parallel line question. We took this away, if we took this away, we start to understand what's happening here. Let me just put my labels in. Now, you may have heard me talk about this as the transversal. It's the line that goes through, let's colour it in, it's difficult to see on there. It's the line that goes through the parallel lines. Now I have 2 transversals here, but the one that the X is on is this yellow line. This has nothing to do with this question. We are looking at the relationship between the angles that are on the transversal that X is on. It goes through those 2 parallel lines. This is a corresponding angle question. We can see that those 2 are the same. Therefore, the answer is D, which is 52. That is a D. 52 degrees. This is 52 degrees. Question 44. I'm going to draw it. 2, 3, 4, 5, 6, 7, 8. Let's draw that slightly differently. Otherwise, it doesn't look like an octagon. In fact, I could do with that line, so I'm not going to rub it out. I'm going to leave it there. So my octagon is the size around the outside. And what you do is you take one point and you draw in all the others. Do make sure you've got 8 sides. Okay, count them, make sure you've got them. I've then got triangles. 1, 2, 3, 4, 5, 6 triangles. Each of these is 180. The angles inside each of these triangles is 180. Therefore, what I'm doing is 6 multiplied by 180, which is 1080. We then want to find the angles. There are 8 identical angles in a regular octagon. So therefore, we do divided by 8 equals 135 degrees. The answer is A. If you know the formula, you might know the formula rather than drawing out an octagon. You might prefer to use the formula if you remember. I'm personally not a fan of the formula. There are reasons for using it. This is the number of sides. I like to see it visually, and a lot of my students prefer that way. You're not learning a process, an abstract process. You can see it's the same calculations, it's just that we get to that 1080 in a different way. We are looking for the difference between when it starts and when it finishes. It sets off at 9:20 and it gets in at 10:08. So we're looking at the time it takes to get from here to here. I'm going to put 10 o'clock in the middle. We know from 9:20 to 10 o'clock there are 40 minutes. 10 o'clock to 10:08 there are 8 minutes. So if I add those two together, I get 48 minutes, which is answer C. The trapezium, let's sketch it out. Often a good idea to sketch something out. This is for 7.2. 8.4. I'm going to label this with an A and this is our B. This formula is on the formula sheet. Either looks like this or it's exactly the same thing. How it appears on the formula sheet is this. So either this or this. Lots of students prefer to remember it this way, but this is how it looks on the formula sheet. It is a good idea to memorize this. Area equals A is 7.2 plus 8.4 multiplied by the height divided by 2. This is 15.6 multiplied by 4 divided by 2. You can just put this into your calculator. The answer is C. Okay. Now, technically this is a prism. And although it's a cuboid, this works with any prism. That's a shape that you've got a 3D shape that you've got the same shape that goes all the way through. So this end is the same if we cut it all the way through this shape. So what I do is I take that 5 multiplied by 4, which gets me to 20. Then the depth is 12, so I take that 20. I multiply by the 12, which gets me 240 centimeters cubed. Yes, you can just multiply all 3 together. You can't do that 5 times 4 times 12. If you've got a prism, you have to work out that end area first, like a triangular prism or a hexagonal prism, trapezium prism. You have to do that. So it's why I like to do it in that order. What are we doing? Oh, this question here. We've got this here. We've got a triangle. Oh, in fact, that triangle's going over there. We've got a triangle over here. The line of reflection is going to be here. So it's a reflection, but it's in the line x equals 2. This is the x-axis. We're coming through the middle here, and therefore it's a reflection in the line x equals 2, which is answer D. It says it helps us. This is Pythagoras' theorem. We know exactly what we need to be using. This is a formula on the formula sheet. We are being asked for line BC. BC is this one just here. A squared plus B squared equals, I'm going to call this, which way around did I do it? A is 18. This is A. This is B. I'm actually going to call it H squared. Some people call it C squared. I like H because it is also the hypotenuse when it comes to trigonometry. You can see it like this. Some students actually do the subtract version, or B squared equals H squared subtract. So it's the subtract because we are trying to find a short side. B squared is a short side. So I'm just going to turn this round so it's B squared. Doesn't matter which side it is. All I've done is reverse those. So x squared equals 23 squared subtract 18 squared. Oh, I've missed a step out. Let's put that step in first. Let's not skip ahead. Right, x squared is 205. The inverse of squaring is 2 square root. Yeah, no surprises there. This equals 14.31782, which simplifies to 14.3. The 1 means the 3 doesn't change, and that's answer B. Okay, question 50. Again, it says it's trigonometry, gives us a helping hand when it comes to working out what sort of question it is. I'm going to label it my longest side, my opposite. I'm going to remember I do not need the A here. I've got the H and the O. So we're looking at SOP. However you create your equation here, it's the angle we don't know. So it is the S, the sine. Sine x equals 28 over 40. Sine x equals opposite over hypotenuse. This is where we use the inverse sine button on our calculator. You could have worked this out first. I like to put all this in my calculator. And that's answer D. '51, we measure it. You use a protractor. We line up the crosshairs right at the end. I'm actually going to put a spot here. It can help me to make sure that I'm putting it exactly in the right place. And there's a bit of trial and error. We've got to be careful it's still on the dot. We've got to be careful it's on the line here. we count forward from that 0. So the 0 is coming round here. It's is it exactly 25? Is that what's in the answer? No, it's just past 25. You can see my line is sort of halfway between 25 and 26, but the possible answers here, it is 26 here. Be careful with that protractor. Question 52, bearings. Don't we love bearings? I actually quite like bearings, but lots of students don't. Okay, I'm going to draw this out. Now, I know which way round this goes. So I'm just going to draw it and explain what I've drawn. I find drawing it out a good idea. The bearing of point P from the point Q. Oh, let me just write out my three steps. Ooh. Two bearings. It has to be from north. So bearing, if we're using this as our bearing, it has to start at north. We're measuring from north. It has to be clockwise. And it must have 3 digits. So what have we got? The bearing point P from point Q. Okay, so P from Q is like saying home from school. Where do we start? Well, we're starting from home from school. We're starting here. So we're starting at P, point P from point Q. Here. P from point, we're starting from point Q. Aha, so this is where we start. P from point Q. There we go. I knew I'd worked it out. So we're doing this. So 208 is roughly around here, but if you'd sketched it the wrong way round, not a problem, but I would definitely sketch this out. 208, I'm starting at north, I'm going clockwise, and I've sketched this to be somewhere between 180 and 270. It's a bit far round, but it'll do for what we're doing in terms of a sketch. You could use your protractor if you wanted to. There is no need to be able to work this out. We need to find the bearing of point Q from point P. So this is 208. We're now going to go from P. So what I'm going to do is I'm going to work out this angle first, which is my 180. No, it's not. It's my 360. Subtract 208. This gives us, this is not the way I did it, 360 to subtract 208. My brain's not working today, so I'm going to use my calculator. 152. So this angle here is 152. And then what we've got is we've got this angle here. Now, these are actually parallel lines. So this actually becomes a parallel line question. They don't look very parallel. But if this is 152, then this angle here is 180. Subtract 152. Is 28 degrees. Now it it must have 3 digits. So the actual answer here is 0 to 8. So it must have those 3 digits, therefore the answer is C. So this is what's called a loci drawing. We don't have to do these very often. We can do it by applying some logic. So what we've got here is we've got our line AB, and this section here, which includes the area that we need in this question, is at least, all of these points are at least 9 meters from AB. So all of this section, at least 9 meters. But we don't want all of this shaded. What we want is a distance here that's 6 meters. Now, it is dotted because it is not actually anything on the line. It is everything in front of that line. So I'm just thinking of another colour. Let's get another colour. This pink here, the pink is everything that is less than 6 meters from D. And the only option that we have here that meets both of those is at least 9 meters from AB, that line here, and less than 6 meters from D. We use a circle to do that, and that is answer C. Question 54. We have a circle. It has a radius of 10 centimeters. We work out the area. It is a formula on the formula sheet. So this means pi radius squared. We have to do the radius squared first. Pi times 10 squared. 314.159. And we round that to 314. Question 55. Sectors of circles are tricksy to understand. We've still got a circle of 5. We've got a radius of 5 centimeters. It's still a circle. We're looking at a fraction. We want to know the fraction of the circle that is shaded. The way that we find the fraction is we do the degrees divided by the total number of degrees around the point, multiplied by pi, multiplied by r. This is pi r squared again. So this is still pi r squared. We put this into the calculator, we get which is answer C. So very similar to this question here. It's just that we're putting this fraction in front of it because we need just a sector of this circle. Again, another circle question. We need to know the area of a circle again. This time the circle is the area of this end. We're back to prisms again. Cylinders feel like they're not necessarily a prism, but they are. Same process. We want to find the area of this end of the circle. Call it the base. So we're back to our pi r squared. Oh, it's 6 this time. And we are multiplying it by the length in exactly the same way we did with the cuboid earlier. The length or the depth or the height in this case, we are taking 113.097 multiplied by 10. 9 rounds up to 1. 1131 centimeters cubed. Similar triangles. Now, that one's on the side. It's difficult to relate to this one. So what I'm going to do is I'm going to put them both standing up. I'm going to make one triangle significantly bigger than the other. I can see that that's 20 and that relates to that 15. So this is your bigger triangle. This is A, B, C, I've just turned that triangle up here. So ABC, 21 is the longest side here. And do it, turn your paper around. PQR is 15 centimeters, and we're looking for this length just here. We do it by looking at the big divided by small. Right, the two corresponding are this one and this one. This one and this one are related, but these two are the ones that we can use to find the scale factor, also known as the linear scale factor. Now, I could put this in my calculator and get a 1.33333, but I'm not going to do that. I'm just going to use it as a fraction. To get from here to here, we have to multiply by 4.3, and that's exactly the same. In fact, no, it's not the same. We are coming back, and therefore we're dividing by 4/3. So we're taking 21 divided by 4/3, which gives us 15.75 centimeters, which is D. Now, the correct answer here is A. If you think about it, congruency is when they are exactly the same size, same lengths, same angles. If we thought about an equilateral triangle, we could have an equilateral triangle that has the same length sides and the same angles. This is a small version, but we can also draw an equilateral triangle that has 60 degrees. All the sides are the same as each other, but they are different from the smaller equilateral triangle. So all three angles are equal. Well, they're equal here and here. This is not congruent. This is not a measure or a check for congruency. It actually says a condition. It's not a condition of congruency. Question 59, vectors. Now, vectors can look a little scary. If you don't remember them before, it's like adding and multiplying. We want P subtract 2Q. So I'm actually going to work out 2Q first. 2Q is the same as 2 multiplied by the top of the vector and the bottom of the vector. If you're not sure on negative numbers, go back and check your negative numbers. It is incredibly important to be able to get these right. So we're subtracting, we're taking P and we're subtracting 2Q. So this time we're putting P and we are subtracting 2Q, which are these. Negative, we are subtracting -6. Be careful of those negative numbers. We are switching here between multiplying negative numbers and subtracting negative numbers. If you got this wrong, you got the process right, but you got this wrong because you got the adding and subtracting wrong, absolutely need to nail negative numbers, switching between multiplying and adding and subtracting. We take -2 and we subtract 6, which gets us to -8. And then 5 subtract -6 is exactly the same as saying 5 add 6, which gives us 11. And therefore the answer is D. Two-way table here. I've copied it directly from here. I'm going to complete it. I have 5 and 2, so it's 5 subtract 2 gets me 3. 3 add 12 gets me 15, and I like to complete it, even though I don't need that in this question. I'd like to complete it to be sure. And sometimes you actually are asked to complete the whole thing. 5 plus 16 is 24, but I also check the other way as well. 9 plus 15 is 24. It means that I've done an extra calculation, but then I know that this is correct. we want to know how many boys were in the class in total, which is this number here. 15 is answer B. This is called a pictogram, and what we've got here, Nicola, 1, 2, 3, 4, 5, 5.5, 2, 3, 4, 5.5. Each circle in the key represents 10. So this is £10. 10, 10, 10, 10. And this is half. So this is only £5. 50 here plus 5 equals £55. And that's answer A. Pie charts. 100 students. 35 chose blue. Just sketch a picture. So 35 students out of 100 students. Like we did with sectors of a circle earlier, we find out the fraction of students to the whole. This isn't 360. What we're doing is 35 out of 100. So we put it as a fraction. Then we multiply it by 360. It means that this angle here is 126. That is actually the answer that we need, which is D. Question 63. Scatter graph. Whenever I see a scatter graph, I instantly want to draw a line of best fit with a ruler and a pencil. We don't need it for this if we can see the direction that this is traveling, but it's not a bad idea to put, whenever we see a scatter graph, to put a line of best fit. This is what's called a negative correlation. It says that here the answer is D. If it was going this way, it would be a positive correlation. And generally, we have we only call it negative or positive, or no correlation if they were all over the page. Now, 64 is interesting because I can't get to the right answer. Partly I can't get to the right answer because it says there are 10 Satsumas, and actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 Satsumas on here, so I'm going to write do not do. Now, you will see that I have changed the orientation, the way that I've written this question. We are most likely to see a question this way round, with the goals 0, 1, 2, 3, 4 in a column rather than a row, and the frequency next to them. So in order to explain this question, I'm going to do it this way round. If you add these together, we're told in the question there are 40 matches. There are not just 5 matches, there are 40 matches altogether. 11 of them had 0 goals. 15 had 1 goal. What we're going to do is we're going to work out how many goals were scored in total. In these 11 games, 0 goals were scored, so it becomes 0 multiplied by 11, which is just 0. In 15 games, 1 goal was scored, and therefore we can do 15 multiplied by 1, which gives us 15. 16, 15, and 4. This might well be on a non-calculator, I think. It could be. We're going to add these together. Adding these together gives us 50. And then the mean is the total. This is the mean. Total over the number. So the total is 50, total goals, over the number of games. let's put off games in here. Total goals over the number of games, 5/4, which is the same as 1.25. You can put that into your calculator. A useful check is to make sure that this number fits somewhere in here. If you got a number that was, what we do, 50 times 4, 25, 12, 12.5, there isn't the average number of goals scored cannot be greater than 4. It's likely to be around 2, 1, 2. It cannot be 12.5. So this is what we do. We have to divide it by 40. You need to read down here the only the only answer that does not describe a random sample is it. Okay, 67. Six-sided dice is rolled. There are 6 different outcomes. 1, 2, 3, 4, 5, 6. Of these outcomes, there are 1, 2, 3 even numbers, landing on an even number. So it's 3 out of a possibility of 6, which is the same as a half. It is 0.5, but we've got a half here. This is answer C. We know that all of these need to add together to make 1. If we add these together, 0.1 4 times is 0.4. These will make 2x. X plus x is 2x. So we can create an equation. 0.4 add 2x equals 1.0, or just 1. Subtracting 0.4, and now we're going to divide both sides by 2. Question 69. Bag contains 7 counters and 7 black counters, 3 white counters. Now, I could just do this as a straightforward multiplication of fractions, but I want to show you why. Sometimes with these questions, it actually is better to draw out a probability tree. We choose a counter, it's either black or white, put it back, and we either get a black or a white. Probability of getting a black, 7 out of 10. There are 10 counters altogether in the bag. And we've put it back, so we've got the same. Now, on a foundation paper, this table will usually be drawn, but it might not. When we are finding a white and a white, 2 white counters, we are multiplying across. We take 3/10 multiplied by 3/10, put it into a calculator, or know that that equals 9/100ths, which is answer D. So I've drawn out the Venn diagram. I've put them slightly differently in that I've grouped them together. I've put all of the numbers around the outside, for instance, up here so that they're easier to see. Now it says A in union with B. This is the same as A or B. So a number could be in A on its own. The number could be in B. The number could be in A, both A and B in the center here. We are looking at everything that's in A. Everything that is in B is the whole of this area here. So we've got 1, 2, 3, 4, 5, 6, 7 out of the whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 7 over 11, which is A. A in union with B, which is this area here. It's all over everything that is shaded here. Well done. If you managed to get to the end of this paper, I am so impressed. I know it will have taken you a long time. It took me at least 2 hours. I'm expecting it probably took you longer. So very proud if you've got to the end of this paper. You really want to get these right. Remember, these questions were hard. They were the hard versions of all of these questions. So I hope by breaking them down a bit, they've helped you to work out how to do it. What you can do though is if you need help, one, there are some references on the Pearson Revised Guide, but also these headings give you the opportunity to Google this as a topic to be able to find more questions like this. So there will be more questions on Maths Genie in particular. mathsgenie.co.uk. Let me just, yeah, mathsgenie.co.uk, and you can put in something like Venn diagrams. If you search in the search bar for Venn diagrams, it'll bring up some more questions like these that vary in their complexity. So as I say, well done. I am really proud that you managed to get all the way through the paper. I look forward to supporting you again.